This presentation is on the sequence diagram of the Unified Modeling Language, or UML. It focuses on order of events of an object in relation to other objects within a system. Sequence diagrams have many uses, not only to software developers, but also to businesses as well in modeling company plans, practices, and ideas before implementing them. Sequence diagrams are most often used to represent interactions between the different objects of a system, creating a view of the messages, requests, and data flow. In this view, the expected behavior of the system becomes better visible to the stakeholders and aids them in fulfilling requirements. Objects are generally represented as boxes listing their name, class, and/or classifying designations. Paired with a vertical dashed line, they are called lifelines. Arrows between lifelines designate the interactions between them as well as a type of interaction.
This diagram will go over the topic of what happens at a restaurant that we are wanting to eat at. This is a simple broken down representation of the interactions between the customer, the waiter, and the chef. A sequence diagram for a computer system would have many more objects and be much larger. First, you will want to place your objects in a sequential order from left to right. Next, you will need lifelines, which are the vertical dashed lines which show the existence of an object over time. Moving down the lifeline means that more time is passing. The customer will order their food from the waiter or waitress. This is represented with a solid line arrow as a message. The next message is the waiter placing the order with the chef. And you can see that the place order message is just below the order message, showing that this is next in the sequence. The waiter then sends a message back to the customer. This is called a return message and represented with a dashed line. This is done in the form of a customer getting their drinks that they ordered. Lastly, we have our activation boxes, which are the black vertical boxes. These show when and how long an object is performing a process.
Let's take a moment to discuss the pros of the UML sequence diagram. First of all, it forces you to work out the system's object interactions. It also creates a good way to show use cases in a refined and formalized way. It can document how a current system's objects interact and is widely used by businessmen and software developers to understand system requirements in new and existing systems. These are all very helpful points of the UML sequence diagram, and is why it is used so widely. However, there are some cons as well. One of those is that although it can depict object interaction, it's not a very good way to model control logic. Another disadvantage is the time it takes to manage and maintain UML sequence diagrams. To work properly, UML diagrams must be synchronized with software code, which requires time to set up and to maintain, particularly as the code and the design changes over time. Also, the formalization of UML sequence diagram is sometimes hard to deal with for non-expert users. The first time they see it may be very confusing for them. So we recommend that you use a UML sequence diagram to document object and class interactions and messages, and to show the dynamic portions of your project. If you consider a service to be a high-level method used by different clients, a sequence diagram is an ideal way to map that out. Thank you for listening to our presentation on UML sequence diagrams, and I hope that you enjoy using them in your projects.